Hello friends, welcome to Homeschool. In today's lesson, we're going to look at length of a chord. In previous videos, we've defined that a chord of a circle, you're given a circle, and we defined in previous videos that a chord is that line that runs from one end of the circumference to another end of the circumference. So this is a chord. And we also said that the chord that runs across the middle or the center of the circle, if we take this to be the center of the circle, and a chord runs across the center, we call this very chord the diameter of the circle. So this is the diameter of the circle. All right. So now we're looking at this very chord. This chord is not running through the center of the circle. So this is not a diameter. All right. Now we'll be looking for the length of this very chord. Now let's take, for instance, that this is point A. And let's label this point B. So this point A is B, this point is A. Now, if we assume here to be the center of this circle, we'll have a radius. That's a line that runs from the center to any point on the circumference. This is a radius. Let's have another radius running this way. So we'll label this R, label this R. Now, an angle is subtended at the center here. We can call this very angle. Okay, let me make the circle bigger. Let me make it bigger so that it will be clear for every one of us to see. So this is a big circle. This is the center of this very circle. All right. Now I have a chord running from this point to this point. I will label this point A. Label this very point B. Now, a radius is a line drawn from the center of the circle to any point on the circumference. So this is a radius. This is also a radius running from the center to any other side on the circumference, to any point on the circumference. So this is also a radius. They are equal. So R is equal to R because they are running from the center to a point. Now, an angle is subtended at this very center. Let's call or label this angle theta. This is our theta. Angle subtended by this very chord at the center. We'll call it theta. Now, what are we required to find in this very lesson? We are required to find the length of this very chord. We are looking for length of this very line, line AB. This is line AB, the line running from A to B. So we want to find the length of this very line. And this very line is called a chord. So how do we find the length of a chord? Now, the first thing we need to do, we need to divide or bisect this very line. Let's bisect the angle. And of course, when we bisect the angle, we'll end up bisecting this very line. And how do we do that? We will draw a perpendicular line running from the center to this very point. Now, the very center of this circle, let me just label it C. Let me label C. That this very point is point C. Let me label it point C. And I want to bisect this very triangle. Triangle ACB. I want to bisect it. So I will rule a perpendicular line from the center to this very point. So when I do that, let me rule a perpendicular line. Look at this very line. This line is a perpendicular line. And because it is a perpendicular line running from the center, it will bisect angle theta into two. It will divide angle theta into two. So it means that this part is going to be theta over 2 and this other part is going to be theta over 2. So here I have theta over 2 as the angle, and this very part I also have the theta divided by 2, theta over 2. That's the angle I have here, is bisected. Now, the very point where it bisects this very chord called AB, because this is a perpendicular line, an angle is formed here, and this very angle is 90 degrees. That's a right angle. A right angle is formed there. Why? Because this is a perpendicular line bisecting this horizontal line, which is the chord we're looking at. So an angle is formed there, which is what? A right angle. So let me sketch it out so that we can have a better view of what we have just represented above. Now this is what we have. You have your radius running from the center, all right? Then you have your chord. Okay, your chord runs there. We'll label here A, label here B. All right, so this angle is divided. We have theta over 2, theta over 2. Okay, so another thing I need to point out also is that this very point where this very line, perpendicular line, bisects here, let's call this point point E. All right, let me still label it point E. All right, this is point E. The point where this very line bisects this very one, we'll call it point E. All right, now I want us to consider one part of the triangle ACB. Let's take one part of it. So let me take triangle ACE or triangle ECB. All right, okay, let's go with triangle ACE. Triangle ACE. So triangle ACE is now represented this way. It's running this way, all right? And we'll have the line that is running this way. Okay, so remember that this place is a radius. We labeled here C. This point as the center of the circle C. And this point is A. And this other point is, okay, is E. Here is E, please. This point is going to be point E. An angle is also formed here, which is what? 90 degrees. And the angle that is formed here, is theta over 2. That's the angle that is formed here, theta over 2. Now, remember that we are required to find the length of this very chord called AB. That's what we're required to find. Now, another thing you need to take note of is that AE is going to be equal to EB. What do I mean? What I mean is that because this very line is bisecting AB, it is going to bisect or divide line AB at equal position, at equal points. So meaning that line AE is going to be equal to line EB. Line EB. They will be equal because this very line here running in the middle, we divide this into two equal parts. All right. So this then follows that the length of this very chord, which is AB, that is from here to this very point, AB, line AB, is going to be equal to line AE plus line EB. So it's going to be equal to AE. I will add EB to it. EB. Okay. So when I add up this plus this, okay, this line, when I add up AE plus EB, I will have A to B. All right. So this is what I have here. Now, I would like us to consider this very triangle. This is a right-angled triangle. Let us find the length of this very line, AE. And don't forget that line AE is equal to EB. So let's find line AE. Since this is a right-angled triangle, we can apply the concept of SOHCAHTOA. I believe we all know SOHCAHTOA from trigonometric ratios. Concept of trigonometric ratio, we'll have SOHCAHTOA. Where the SO is sine, we say that sine is equal to opposite over hypotenuse. Opposite over hypotenuse. Now, if you look at this very triangle that is formed, this very triangle here, the hypotenuse of this very triangle is this very line here that is labeled R. That's the radius. That is line AC is the hypotenuse. Why is it the hypotenuse? Because it is the side that is opposite to angle 90 degrees. This is a right angle, and right angle has a value of 90 degrees. So the angle that is formed here is 90 degrees. And the very side that is opposite, that is facing angle 90, is what we call the hypotenuse. So this is the hypotenuse. Okay. And remember that sine is opposite over hypotenuse. So we've gotten that hypotenuse is going to be R. So our hypotenuse in this case is going to be equal to our R, which is line AC. Now, what is going to be our opposite? The included angle is positioned at this point. The included angle is theta over 2. Theta over 2 is the angle at this point. So the side of the triangle that is opposite to this angle is this very side, AE. So AE is opposite to angle theta over 2. So this AE is the opposite. So opposite here, opposite to what? Opposite to the included angle that is given, which is theta over 2. Opposite is going to be line AE. Okay. It then follows that the sine of the angle that is included in this very triangle, which is sine theta all over 2, is going to be equal to opposite over hypotenuse. So where is the opposite now? Opposite to the angle theta over 2. Opposite to this very angle theta over 2 is AE. That is line AE. Line AE divided by the hypotenuse. That's the formula for sine. Divided by the hypotenuse, and this is the hypotenuse, R. Okay, so our interest here is to find line AE. We want to find the length of line AE. And how do we do that? Of course, we can cross multiply. Okay, so this is sine theta over 2. That's the angle. So let's cross multiply. If we cross multiply, make this one to be over 1. That's this multiply this, and this very side multiplies this. When I do that, I will end up, what I'm going to have is line AE will be equal to sine theta over 2, that's the included angle. Okay, because this is multiplying this. And okay, this is also times 1. Okay, so this times 1. Line AE times 1. Okay, so line AE times 1, of course, is still going to give you line AE, because anything multiplied by 1 is that thing. Okay, so sine theta over 2 times R will give me R sine theta over 2. This is what I'll end up getting, R sine theta over 2. So remember, before now we established that line AE is equal to line AB. So if AE is R sine theta over 2, it also follows that line EB, that's a line running from, look at it, line running from E to B. All right, so line EB will also be equal to R sine theta all over 2. Why? Because we established initially that line AE is equal to line EB. Okay, now let's add them up. Let's add them up. It therefore means that the length of the chord AB, will be equal to AE plus EB. So this is our AE, that is R sine theta all over 2, okay, plus EB. My EB is still R sine theta over 2. Why? Because they are equal. They are equal because this very line is a perpendicular line that bisects this line into 2 equal parts. So now let's now add up. When we add up, this is what we're gonna get. We're gonna get that line AB, which is the chord we are interested in, is going to be equal to this plus this is going to give you 2R sine theta over 2. All right. So this is basically the formula for calculating the length of chord of a circle. The length of chord of a circle. With this formula, you can calculate the length of a given chord. Once the radius is known and the included angle is known, so you can be able to calculate it. In this lesson, we've been able to derive a formula for calculating the length of chord of a given circle. Let us now apply this in a problem and see how this formula can be used to solve a given problem. Look at the problem before us. The question before us says, it says we should find the length of a chord of a circle of radius 6 centimeter. The radius is given to be 6 centimeter if the chord subtends an angle of 80 degrees at the center. So what are we required to find? We are required to find the length of a chord of a circle. All right, let's look at the solution. First of all, it is best we sketch this very chord, or rather this very problem. You have a circle here. Okay, now let's take this to be the center of the circle, and this is the radius. The radius we are given that R is 6 centimeter. So here is 6 cm. This side is also 6 cm. And we are told that the angle subtended at the center is 80, meaning that theta is equal to 80 degrees. So here we're going to call it 80 degrees. This is the angle subtended at the center. Now, what are we required to find? We are required to find this very line. That's the length of the chord. This is the chord. Let's label this chord AB. All right. This is the length of chord we are required to find. Now, from the formula we derived, remember we derived this formula that the length of chord AB is equal to 2R sine theta divided by 2. This is the formula we obtained. All right, so now let's apply this formula. So the length of chord the chord is line AB in this case, is equal to 2R sine theta over 2. We derived this formula earlier. Okay, so let's now apply it. Of course, we know our R. The radius is given to us to be 6 cm. So it follows that AB, length of the chord, is 2 times R, which is 6, times sine of the given angle. So we divide it by 2, which is 80 over 2. So, of course, 80 divided by 2 is giving us 40. So it follows that 2 times 6 times sine 40 degrees. Okay, so we can make this 40 degrees. So 2 times 6 is giving us 12 times sine 40 degrees. So what is sine 40 degrees? With your calculator, you can check it out. Okay, so using your calculator, you can get it that sine 40 degrees is giving us 0.6428. That's what sine 40 degrees is giving us, 0.6428. So now multiply this 12 times 0.6428. When you do that, what you obtain is 7.7. Of course, it's going to be in centimeter. Why is it in centimeter? Because the radius is given to us, is in cm. So the length of the very chord we calculated, it will also be what? In centimeter. So friends, this is how to basically solve or calculate the length of chord of a given circle. So remember that the formula for calculating the length of chord of a circle is 2r sine theta over 2. We've been able to derive these formulas. Alright guys, I would like you to look at subsequent videos on circle theorems and familiarize yourself with it. Do not forget to like all our videos.